Hi everyone, I'm Kamala, Assistant Professor from CSC Department. Today I'm explaining about issues in the designing of code generator. So before going to the issues in the design of code generator, first of all we discuss what is a code generator. Code generator is the fifth phase of compiler designer, which takes source program and producing output in the form of executable machine code. Or else, this code generator is the fifth phase of the compiler designer, which takes input from the next before code generator phase is called as a intermediate code, so which takes input from the intermediate code in the form of uh, intermediate forms, that is nothing but a syntax tree or postfix notation or three address code. So this is the input of code generator, and finally producing output in the form of machine code. Okay, so the design of code generator should be done in such a way so that it can be easily implemented and easily tested and maintained, because this code generator is going to producing the final output of the program. Okay, now we'll go for issues of this code generator one after the other. The first point is input to the code generator. So this, according to the code generator definition, we'll discuss what is the input of the code generator and what is the final output which is going to producing. So the input to the code generator, the input to the code generator is nothing but a output of intermediate code. So here the intermediate code is nothing but a fourth phase of the compiler designer, and this code generator is nothing but a fifth phase of the compiler designer. So this code generator taking input from the intermediate code in the form of postfix notation or syntax tree or DAG or three address code. Again, this three address code is represented in the form of quadruples, triples, and indirect triples. So finally, the input of this code generator is nothing but a quadruples, triples, indirect triples, postfix notation, syntax tree, and DAG. So this is the input taken by the code generator. And then what is the output produced by the code generator? So that is called as a target program. So this code generator taking input and producing output in the form of the following is called as absolute machine language, then relocatable machine language, then assembly language. So what is the absolute machine language? This absolute, in the name itself, it contains absolute, means the right of output. So this absolute language as the output has the advantage of this absolute machine language is it can be placed in a fixed memory location and can be executed immediately. So that is the advantage of absolute machine language. So it is producing the output, and that output is placed in some fixed part of memory location and is executed immediately without depending on any other code. And now coming to the relocatable machine language. So this relocatable machine language allows subprograms and subroutines. So during the execution of this machine language, so which also allows subprograms means which are implemented separately and executed. So during the execution of this program, this relocatable machine language allows all the subprograms and subroutines uh, to do this, which is going to depending on a linker and loader. So the job of this linker means during the execution of these subprograms, taking the execution part of that subprogram and adding to our program by using a concept is called loader. So here this linker and loader is expensive. So because of that, this relocatable machine language is an expensive one. And now and which is also taking the time for executing the program, because every time which is going to depending on linker and loader. Now the next type of output is called assembly language. So this assembly language is output makes the code generation easier. Why? Because the code which we represented in the assembly language is called as symbolic instructions. To write this symbolic instruction, which is going to depending on a macros. So this is about the output of assembly language. Now the next one is called memory management. So what is the memory management? Generally, every source program consists of names. So the mapping of these names in the source program to the address of object is done by front end and the code generator. Okay, here a name in the three address statement refers to the symbol table entry. So in this three address code, uh, each statement is having some names. So these names refers to the entry of the symbol table. Here the symbol table is nothing but a data structure which stores the data during the compilation. Now the next issue is called as instruction selection. This instruction selection is nothing but a selecting on the best instruction will improve the efficiency of the program. So to improve the efficiency of the program, definitely which depends on the instruction selection. Here the instruction selection plays uh, an important role because which this instruction speeds and mission idioms also plays the major role when the efficiency is considered. So if efficiency of code is considered, then the speed of the instruction and the machine idioms also plays a major role in this instruction selection. Otherwise, if you're not if you're not considering the efficiency of the program, or we are not giving an importance to this efficiency of the program, then straight away we can select any instruction and execute the program. So this is about instruction selection. For example, if I have uh, some source code is called as p is equal to q plus r and s is equal to p plus t, and this code is represented in the form of assembly language is represented as below. Here I have q plus r. This q plus r can be represented as moving the statement r into q. Okay, sorry, here move r0. Here the register or this particular instruction I'm shifting into a register is called as r0, so that this q value is available in r0. Now this q I'm trying to add into r, so that q is available in a register is called r0. That r0 directly adding to r means add r to this r0. So adding q and r, finally storing the result into r0. So this is the meaning of this statement. And again uh, move r0 into r0 means after adding these values I'm shifting this r0 value into r0. So because the result of q plus r is available in r0, finally I'm shifting this r0 into r0. Now the next one is uh, p move p, which means here I'm moving the final result R0, final result R0 into P, because here I have a resulted variable is called P. This P is handling the result of Q plus R. That Q plus R is available in a register is called R0. That R0 I'm shifting into P. Now the result is over. Now here I have one more instruction is called P plus T. So that p plus t, here we can also represent move move p, or else move that r0 So here I'm shifting P value into another register is called as R0, and similarly this T I'm adding to P. So P is already available in a R0. Add T to R0. Now the final result of R0 is available in R0. So here that move R0 means moving this R0 into S. Okay, so this is about the implementation of the source code in the form of assembly language, or else we can also represent it as move R0 into S. Hmm. Move R0 into S, or else we can also write like this. Okay, so the final result R0 I'm shifting into S. So this is about the implementation of assembly code for the given mm, source program. Now the next issue is register allocation issue. So this is also an important topic in this code generation. Here we have two types of register allocation is called as a register allocation. The second one is called register assignment. So using this register allocation, which automatically allocating registers for a set of variables is called as register allocation. And coming to this register assignment, which is selecting the specific register to that particular variable. So that is the difference between register allocation and register assignment. So using this register allocation during the execution of the program, based on the availability of registers, the compiler automatically allocating each register to each variables. But coming to register assignment here, which is going to searching for that particular register. Okay, suppose it is searching for register, say R0. So if the R in this situation, if R0 is available directly, which is going to allocating. If R0 is not available, then which is moving to R1. So that is called as a register allocation. And coming to register assignment, which is searching for that particular or specific register, suppose say R0. If R0 is already allocated by some other variable, in that cases if there is no space to store the next variable into R0. So because of that, this register assignment taking a lot of time, whereas register allocation takes less amount of time, because uh, by the time being the variables are stored into the available registers. But coming to register assignment, it is not like that. So which is waiting for that particular or for that specific register. So that is the difference between register allocation and register assignment. Now the last one is called evaluation order. So to produce the accurate output or the final machine code or the efficient code, this code generator is also depends on the evaluation order. So this evaluation order also finally giving the good machine code. So based on this evaluation order also, which is producing the good target program. Okay, so this is about evaluation order. Now approaches to code generation issues. The code generator must always generate the correct code. It is essential because of the number of special case that a code generator might face. So some of the design goals of this code generator are correct, easily maintainable, testable, and efficient. So these are the some of goals to implement this code generator. Okay, so this is about the issues in the code generator. Okay, thank you.